Greetings again. Another video about building this little dog trailer. As promised, I wanted to speak about how I actually work out what sort of steel it is and that I use in my trailers and how I calculate things and just a general rundown on that, I guess you could say. I personally am not a structural engineer, but I've been in the fabrication game for a very long time. Mechanical, carpentry and fabrication areas, that's my sort of call to fame. So as a result, I normally build trailers for myself. I don't sell them. But I just thought I'd speak about materials. And as we went in our first video, we're talking about 100 by 50 by 3 mil. And this is the main chassis rail that's connected to our tow point. So this is at the front of the trailer. Here we got 50 by 50 by 3 mil, and it's welded to the base or the top of this 100 by 50. So 3 mil. How would I work out 3 mil? So if we go back to the ADRs, or this is in the trailer manufacturing section, this comes to drawbars. And so I work on the basis that the drawbar is the thing that takes the most amount of weight and it's the most susceptible to breaking. And drawbars on dogs, pig trailers, the whole kit and caboodle are all exactly the same. So legislation says that, or the guide says, longitudinal tension and compression. So my simple understanding of that is you're trying to pull it away. You're trying to pull this away this way. That's longitudinal tension or compression. So tension, you're trying to stretch it. Compression, you're trying to push it together. Transverse thrust is effectively we are skidding the trailer around on itself. So if we go back to our dog trailer, a little pitch here. So with the dog trailer, that point in there, if you're turning the dog trailer, one wheel is going in one direction and the other wheel is skidding in the opposite direction. So that is transverse. So in that point there, this particular chassis wants to try and bend sideways. So it wants to bend this way. So it wants to go sideways this way. So transverse load. And then vertical tension is basically the weight of how much flex this chassis or drawbar is when it is loaded. So it naturally wants to bend. So that's my simple understanding of it. Please correct me if I'm wrong. So over the years, just playing around, welding different things and fabricating different things, I've come up with sort of like a simple model. And I went onto the great Google and came upon a beam calculator. And I think this is from Sunset Patios. So if you do a deflection beam calculator, you can put on your details. So we go right to the top of this. Length in mils is 2,000. Load in kilograms. So we are talking about that we are putting the load on this lump of 100 by 50. We're putting it in this way. So we're going to put 1,500 kilo on that beam. And then continuous load, so that's the actual structure, so effectively the trailer, of 600 kilo per metre. So the amount that we're putting between these 2 points is 2,700 kilo by this calculation. And of course you can select the type of material. So 2 metres is quite far, and then it goes through all this hoggly-doo that engineers just get excited about. But basically the thing that I'm really interested in is beam deflection. And it breaks it down into the mathematics, of course. So I'm interested in beam deflection and also the MPa. So up the top here, it comes with deflection under its own load is 0.06, so nothing. Deflection under load is 10 mil, so that's how much it bows. And then the continuous load is 5 mil. So in other words, you're bending this 16 mil with its load, and you're putting a maximum stress of 469 MPa on it. So Australian-made RHS must meet 450 MPa. Now, with my calculations, when we go back to this, we go through all this sort of crap, that's for one piece. So in this situation with the dog trailer, we've got 2 chassis rails, so we halve it. So it comes down to 230 MPa. So the minimum requirement for steel is 450. So in other words, this particular chassis rail you see here is only half of its deformation rate. So I've got twice as much capacity. And then when you put a coaming rail on the outside of it, so we've actually got 4 rails working here, if that makes sense, that are supporting the weight. And they're all pinned together and they all work as a beam. So this is how I actually work out what I'm carrying. There's never going to be 2,700 kilo in 2 meters of this trailer. Because the first thing, of course, we've got a toe ball at the front. That's a pivot point. And then when we go to the axles, we've got pivot points too. And, of course, any smart builder is going to put all their weight over the axles. They're not going to put it in the centre. So that's how I work out my beam strength. So in terms of welding, one thing that I've learned over the time is that cracks happen. It's just a part of life. So I thought I'd just go through and explain how I sort of do things. I weld, so this part here is the top of the beam. So, and this of course is the bottom because our trailer's upside down. So as you can see, I weld this all around. That's welded, so I don't want water in this section. So this main beam up here, or the part of our truss, I weld all that around as well. But this part through here is now the weakest part of that beam because that has structurally changed because of welding. So this is where it's going to break. It won't break as much down here because we haven't affected this cord or the top of this piece of RHS, but we have here. So what I'm going to do is I'm going to actually put a gusset through here, and I'm going to spread the weight along here, or the force along here. So you'll see that gusset going very shortly. So that's how I sort of make things work. And I build strength into my trailers by making sure that they exceed what I think they're going to do. So if you're going to build a trailer and you see somebody else's trailer on the road and they've used different styles of material, best way to find out whether or not it's strong enough is to copy what's already out there. So if somebody's using 150 by 50 for a long pig trailer, so the axles are in the middle, there's a reason for that. So sometimes the engineers and that sort of stuff in other builds on trailers give us the answer. But I'm confident, I'll get the right word out, that because I'm running, firstly, we've got a truss unit here. So we're actually building this really strong. And we have only got 1,400 mil here of beam flex. So this trailer is not going to go anywhere. And so for our transverse, I think the word's transverse. Yeah, transverse thrust. Obviously, you would put triangles in things and what have you, but that weld across there at 50 mil, and we might have 11 or 12 of these tubes welded into this structure. So this is all becoming a strengthening point. So 12 50 mil tubes means that there's 600 mil bracing here down this down the length of this chassis. So that's where you get the strength from. So it doesn't want to bend. So we're creating little squares, and that's where we're getting our strength. The same thing with our axle points. Like we're going to put spring hangers right here. and then there'll be one right here. So this is only 3mm. So some trailer manufacturers just have a 50mm point. I prefer to spread it out over probably 150mm. So I put a piece of flat plate along here, and then when I stitch along here and on both sides, that's making it exceptionally strong. The other thing that I've always sort of worked on in this situation here, I just wanted this to close up. When it comes to putting in our gusset here, and I'll just use a piece of RHS that I'll cut on an angle, I'm not going to weld across the front on here. I'll use something like, once I'm finished, I'll use something like a gap filler. Sounds crazy that you would use gap filler on steel, but all we're doing is we're trying to stop the water getting into that area. So that gap filler prevents that. Plus, the benefit is we don't have any weld across there. So now that top cord is not affected, and we've got a weld that's running along, stitched along here, and that's very, very strong. So that's how I build strength into trailers. Other people might disagree. I'd love to know your thoughts. Anyway, enough talking. I better go in and keep stitching on that that cone rail on the other side. I'll catch you later.